So we are expected to prove this. A difference of B complement union C complement should be equal to A difference of B intersection C, the whole complement, given that U is collection of all X such that X is a natural number and that X is present between 5 and 20. So all values of X such that X is element of natural number and X should lie between 5 and 20. Probably I will give a lesser than equal to sign there. And we got the set A. Set A is all X such that X is element of natural number, that is obvious, and that X is lying between 5 and 20, and that X is divisible by 3. Divisible by 3. So all these conditions have to be met by the set A, right? And for B, collection of all X such that X is element of natural number and that X is present between X and 20, and one more condition, and that X is even number, that X is even. And let's go for C. C is equal to all X such that X is element of natural number and that X is lying between 5 and 13. X is greater than equal to 5 but less than equal to 13. And of course all of these things are given in set builder form and we will have to obtain the elements. So universal set, that's the easiest one. Universal set is all X element of natural numbers that is lying between 5 and 20. So we start with 5, 6, 7, 8, 9, 10. Let me make it as less than equal to, because all of these things are less than equal to. So it's better that I should have less than equal to there. So less than equal to, so 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So this is the universal set. It starts from 5 and less than equal to 20. And all of these things should be within the universal set. All these sets A, B, C should be within this universal set. And that is the reason I have made it to be less than equal to, because initially I just took it as strictly less than. But apparently I later on realized that these elements are actually hitting 20. And we need to make sure that the universal set is the largest set. And that is clearly acceptable in this case. Set A is actually strictly greater than 5. This is alright, which is within the bounds of the universal set, but strictly less than 20, and X is divisible by 3. So strictly greater than 5, that means we start with 6. The next element would be 9, and then 12, and then 15, 16, 17, 18, 19, and 20. We cannot take that. So this is the set for A. Okay, set B is equal to between 5 and 20 and all even numbers. So 6, 8, 10, 12, 14, 16, 18 and 20. And finally C, all elements of X such that X lies between 5 and 13. So we start with 5, 6, 7, 8. Right, so this is the first step. We need to get it on board, and once we get this on board, everything else is cakewalk. Now B complement. So consider the left hand side. So what's on the left hand side? A difference of B complement union C complement. Now in particular we will consider B complement union C complement. Okay, so we start off with B complement. So we can state that we know that B complement is equal to, from the universal set you take away everything that belongs to B, and that's exactly what I'm going to do. So let me use this instead of writing it again and again. If I were to take away 6, I will end up with 5. I take away 8, I'll have 9 there. I take away 10, I'll have 11. Take away 12, I'll have 13. I cannot have 14, I'll have 15. 16 is there. 17, I take away 18. 19. Right, so this is my B complement. So I have got my B complement. Now I need to extract my C complement. C complement is nothing but from the universal set you take away C. I can put it like this. So this is equal to, let me go to the value of C. So 5, 6, 7, 8, 9, 10, 11, 12, 13. All this goes off, only these things remain. So that is equal to 14, 15, 16. Right, that's there. So now we got B complement union C complement. So these two are united. So that would give me right. Now I need to perform the difference. So therefore A difference of B complement union C complement is equal to my A. I'm writing my A. A is 6, 9, 12, 15, 18. So whatever that we see here should be taken out of A. Okay, minus B complement union C complement. So I'm taking away whatever I see. I see a 9, I take away 9. I see a 12, no. I see a 15, I take away 15. I see a 18, I take away 18. So 6 is there, 12, apparently 12 is not here. So this is equal to 6 and 12. Right, so that's for the left hand side. So now let me just go up and consider the right hand side. Consider the right hand side. So what we got on the right hand side? Right hand side is this. Right, so A difference of B intersection C complement. So in particular consider B intersection C. So what is my B? I need to take you back to the question. My B intersection C. So I've got a 6, I've got a 8, I've got a 10, and I've got a 12. That's all. 6, 8, 10, 12. That's it. So this is going to be 6, 8, 10, 12. Now this complement. So B intersection C complement means, so therefore B intersection C complement means from the universal set you take away B intersection C. So that would mean my universal set would now be, so that is going to be 5, 7, 9, 11, 13. Now you don't have to put this complement. There's no need for that. So B intersection C complement is nothing but from the union you take away B intersection C, and that is what we have got. Having got that, now we need to take this value. We need to hence A difference B intersection C complement. So from A we need to take away B intersection C complement. So what is A? Let me write down the value of A. A is 6, 9, 12, 15 and 18, and I need to take away everything that belongs to B intersection C complement. So let me do that. So I need to take away 9, I need to take away 15, I need to take away 18, and what do I have? I've got 6 and 12. So if I were to take this as 2, if I were to take this as 1, from 1 and 2, what do we see? From 1 and 2, we get clearly left hand side is equal to right hand side. So we just proved that. Right? So this is a beautiful question